What's going on everyone? You're back with Jono for another quick math lesson. Today we're going to look at how to solve simultaneous equations with elimination again, but this time the variables aren't going to be as nice as they were in the previous video. So what happens is when the coefficients in front of both variables aren't the same, it makes the whole process a little bit harder because we can't eliminate something if the addition doesn't equal 0. For example, in this one we've got 3x plus 4y and 7x minus 3y. We can't just add these together to get rid of either variable so we can solve for the other one. So what we've got to do is pick one of the letters. In this example, I'm going to pick y, and that's because I'm looking for one that is a positive on the top and a negative on the bottom. And what I've got to do is multiply the first line by the coefficient of the second y and multiply the second line by the coefficient of the first y. What this is going to do is make sure that both of the y's are exactly the same, so then we can eliminate them. What's really important is that we multiply the whole equation by the number that we choose. So we're going to go through this example and see it's really similar to what we've done previously, but there's just one step at the start. You'll find here that labeling is really important. I know that feels like something that's a bit trivial sometimes, but if you do it, I guarantee you're going to pick up extra marks as we go. So I'm going to call this one 1 and this one 2. And what I've got to do is multiply all of 1 by 3. So I'm going to times this whole thing by 3. And at the same time, I'm going to multiply all of 2 by 4. So this means that I've got 9x plus 12y equals 33. Make sure you do multiply everything. That's something that my students do get wrong sometimes. So just make sure none of the numbers are the same as your first one. And I'm going to call this 1a, just to make sure I don't get confused when I'm subbing in. And then I multiply that whole second line by 4, which gives me 28x minus 12y equals 4. This is really good news because we can see there that the y's are going to get rid of each other. And I'm going to call this one 2a. So now I add 1a and 2a, so that's my next step. Add 1a and 2a. Again, write that down. You do get a mark. You can't just get a new equation. So if you tell me exactly what you're going to do, if you make a mistake, you can still pick up a mark. So 9 plus 28 becomes our 37x plus 12y minus 12y eliminate each other, and that's equal to 37. Divide that over, x becomes 1. So now we've got the variable and we need to sub this back into one of our original equations. You can sub it into 1a or 2a, but it's just easier to go back into 1 or 2. Again, I try and minimize the amount of negatives just to make sure that there's no margin for error, that I make a silly mistake that costs me a mark down the road. So I'm going to sub into 1 because there's no negatives there. So I'm going to sub x is equal to 1 into 1. So using those circles again will help your working be a little bit clearer. So this is 3x plus 4y. So I've got 3 multiplied by 1 plus 4y is equal to 11. I minus that 3 over, so 4y is equal to 8, meaning that y is equal to 2. Now again, because we are using two linear equations at the same time, we are technically finding the point of intersection. So we have to write these down as coordinates. Again, it'll just help your teacher not have to go searching for the correct answer. So at the end, just write bracket, x was equal to 1, y was equal to 2. That's all you've got to do. Thanks so much, guys, and I'll see you later. Just a quick reminder, there are some free worksheets linked in the description below, as well as the notes from this video. If you've got a second, please like, comment, and subscribe to Quick Math for more content every day. Thanks so much. Have a good one.